Hello, grade 10s. Let us turn to page 16 of our booklet and continue our sine calculations. So we used the sine trig ratio last day, which told us that the sine of a given angle, which is our reference angle, is always comparing the opposite sides over the hypotenuse. Now we're going to get to cosine and we're going to get to tangent ratios, which use the exact same kind of information, but different side comparisons. So we're doing and starting with sine, but if we learn sine and get a good grasp of it, man, cosine and tangent will be no problem. So when we used the sine ratio last day, it was to find side lengths. And if you recall, to find side lengths, first step, identify a reference angle. We have to know which angle we're using so we can label the sides appropriately. Because once we label the sides appropriately with opposite, hypotenuse, and adjacent, well, then we can set up the appropriate trig ratio, which right now is our sine ratio. That's all we're focused on right now. And the last thing we did was we then solved for the side by cross multiplying. Reference angle, label your sides, put your trig ratio down, and solve with cross multiplying over and over. Today, we're going to find angle sizes. And the great thing about finding angle sizes, well, we're going to need to identify the reference angle to start. We're going to need to label our sides after that. We're going to need to set up the trig ratio. But we're not going to cross multiply anymore. This is where things will change a bit. But the process is very, very similar. So here we go. Lesson 4. Trig ratios, including sine, can be used to calculate angle sizes. Remember, we talked about this last day. We must use the inverse sine, or it was the second function button on our calculators, to create or convert the decimal to a degree. We didn't use it solving, but we did this in our calculator practice at the start of last lesson. So let's quickly review. If we know that sine of some angle is 0.3456, well, what am I going to do? We need to inverse it. Remember, we punch it into our calculator, and it should show us this little sine to the -1. We put the decimal value in, and that's going to tell us how big x is. So let's pull up my calculator, clear what's there. We want an angle. An angle is second function sine, 0.3456 in this case. Close your bracket, hit enter, and what do we get? 20.2, or a 20-degree angle. Remember, angles can be taken to the nearest whole degree. For C, sine of x, 0.6285. Well, again, finding the angle. So we need to inverse or second function sine, and then we'll put the decimal in. So let's pull up the calculator. Second function sine, 0.6285. Close the bracket, hit enter, 38.9, or round that to x equal to 39 degrees. The only thing I want to add to these is, remember, we talked that the decimal doesn't always have to be used. We might have sine of theta as a fraction. 37/46. Well, two things could happen. Remember, we could turn the 37 over 46 into a decimal because a fraction and a decimal mean the same thing. So we could go 37 divided by 46, and we could do sine theta equals 4 decimal places, 8043. These two things should give the same theta because it's saying the same thing. It's just fraction versus decimal. So remember, we have, if we want, we're still finding an angle, so we still have to inverse sine 37 over 46. So second function sine, remember we can punch the fraction in as a division. Sine of 37/46, hit enter, we get a 53.5 or 54-degree angle. If, though, I did the same thing, second sine, and I used the decimal value that we had, which was 8.8043, what do we get? We get the same angle size, 54. It doesn't have to be done as a decimal. We could use the fraction form of it. If you try C and D, we get 27 degrees for C and 50 degrees for D. You can give those a try. But this now becomes important because we're trying to today find angle size. So let's walk through the process. Here we go. Start with choose an angle for the reference angle. Well, this is a little different today because yesterday we had to know the angle because we needed to know the angle to find a side. Well, if we're trying to find an angle measure, we want to use the angle being calculated for. So if we're trying to find angle X down here, that's our reference angle. I like that arc. It gives me an identification. That's what I'm using for my reference angle. Second thing, we now label the triangle opposite, adjacent, hypotenuse. Opposite across from the reference angle is side opposite. Opposite across from the 90 is always your hypotenuse. That leaves the adjacent side. Now, third step, we want to substitute the appropriate information into the sine function. Well, today, we're finding an angle. So I don't have an angle to put in. But what do we do when I look? I have 3 pieces of information. Which pieces are useful? Well, we have the opposite, so I want to use it. We have the hypotenuse, so I want to use it. We don't have the adjacent, so it's no use to us. So there's why today, opposite and hypotenuse, remember? Oh, there's our sine ratio. Always opposite over hypotenuse. So when we substitute into the sine function today we don't know the reference angle, so we leave it as sine theta because that's what we're trying to find. But we do know the opposite and the hypotenuse. Make sure you label correctly. Make sure you fill it in opposite over hypotenuse, 7 over 15. And at this point, well, we just looked at this. There's 2 things to do. We can convert the fraction to a decimal, 4 decimal places, or we can just say, hey, we're going to work with the fraction. Because what you see now is exactly the kind of thing we were practicing yesterday and up here. Here's our sine theta 37 over 46. Yesterday we did a bunch of these. So what do we want to do? Last step to solve, we inverse sine to calculate the angle measure. Well, like it says, we could work with sine theta equal to 7 over 15, or if you prefer, or your calculator works that way, maybe you have to convert it into a decimal. 7 divided by 15 is 0.4666. So I can use either of these to calculate the size of theta. And what do? Because we're finding an angle, I can't say it enough. Make sure you get the inverse sine or it's not going to work. And the most important thing, I didn't mention this lesson, and nobody said anything to me. Of course, no one's in the classroom with me right now, but no one said anything. Please, ladies and gentlemen, always check that you are in degree mode. You need to be in degree mode or this does not work. So let's figure out the size of the angle. 7 over 15 or the sine theta of 0.4666. So what do we want? Find an angle, second function sine, and we're doing 7 divided by 15, which is the fraction form. 27.8 or 28 degree angle.
Sorry for the interruption again.
Sorry, a little bit of a delay. Got messed up by an announcement there. So there's our 27.8, 28 degree angle. The other possibility is second sine of the decimal equivalent that we had. The decimal was 0.4666. Close your bracket. There's our 27.8 or 28 degree angle. Theta is 28 degrees in this situation, using a very similar process to yesterday. Big difference. When we substitute in, we don't put in the reference angle because we don't know it. And we're second functioning, inversing, whatever you want to call it, to solve. There's no cross multiplying for an angle. It's the inverse sine. Let's try the example at the top of the next page together. See what you get. So again, we're working with sine today. What does sine theta equal? Sine theta is opposite over hypotenuse. Calculate the size of angle theta in each triangle. So again, step 1, reference angle. If we're finding angle theta, let's use angle theta. Step 2, label your sides. I hope this is getting repetitive. Opposite, reference angle is side opposite. Opposite, the 90 is the hypotenuse. That leaves the adjacent. Third step is put your trig ratio down. In this case, again, if we want to find the angle, opposite is useful because we have it. Hypotenuse is useful because we have it. Adjacent doesn't do anything for us in this case. So what does that mean? Opposite and hypotenuse? We're doing sine of theta, opposite 53 over hypotenuse 87. The fourth and fifth step kind of go together. What are we doing? We now solve by inverse signing. We need to inverse sine. So we need inverse of sine, or if you prefer, we need to do 53 divided by 87 to get the decimal, inverse sine for decimal 6091. Let's try it out on our calculator, see what we get. So in this case, second function sine, because it's an angle calculation, 53 divided by 87, close your bracket, hit enter, 37.5 or a 38 degree angle. If you have a calculator that won't work fractions, second sine, you put it into decimal form and you plug in the decimal, 0.6091. What do we get? Same angle because it's just a different way of writing it. Well, I got lucky. This time I forgot my bracket, but it still worked. Try to remember to put that bracket in because it won't always work for you. So we ended up with a 38-degree angle in this case. So for this situation, our angle theta was, I forget what it was, 38 degrees? Yes, it was 38 degrees. Theta is 38 degrees. Pause the video, try this example over here on your own, and then we'll walk through it together. Here we go. We are trying to find angle theta here. Kind of written sideways, but angle theta. So that's our reference angle because that's the angle we want. Label your sides. Opposite, the reference angle is the opposite side. Opposite, the 90 is your hypotenuse. Leaves us with adjacent. But in this case, the opposite and hypotenuse give us information we can use. Adjacent doesn't do anything for us. So sine theta is opposite 12 over hypotenuse 18. So if you want to work with the fraction form, it'll work. If your calculator won't do that, some calculators require you to have the decimal. We're going to work with 0.6666. Either of these now, what do we do to finish? We have to inverse sine one of those to get how big theta is. 12 over 18 or 0.6666. So, second function sine, 12 divided by 18, close your bracket, 41.8 or a 42-degree angle. The other possibility, second sine, if you're working with the decimal, 0.6666, close your bracket, it's still a 41.8 or 42-degree angle. Theta is 42 degrees. So, sine, get these steps down pat. Page 17 and 18 are your assignment. There's not a ton there. You need to finish page 17 and then page 18. There's not a ton there. It's repetitive. You get it or you don't, but make sure you get it. Page 17 is just a bunch of calculator work. You need to know and get it ingrained in your brain that to find an angle, you inverse sine. To find the side length, we cross multiply. You need to keep those separate. Make sure you understand. Check your notes with my key that's provided to you. Make sure you practice. Next day we go to cosine, which is almost the same stuff. Different side comparisons and a different button. Otherwise, it's the same. It's nice. So get the practice done and have fun.